Hi everyone, this video is an exercise 11 in question 9. We want to use a suitable trigonometric substitution for x to integrate this expression. So first of all, trigonometric substitution is something that is actually very common. And in this case, let's just start with the substitution x is equal to sine theta. So this might be helpful here. Now here, one thing that you should be careful is that we set the substitution as x is equal to the trigonometric function rather than saying that let u be sine x, because this complicates things. Because when we want to substitute into x, then we need to do arc sine u is equal to x, which we definitely don't want that. So that's one thing to be careful. Now, so let's differentiate the x. The theta gives us cos theta, and when we rearrange this and make the x the subject, we get cos theta d theta. Now in terms of the limits, so when actually we need to use inverse, because we have, so here we have the value of x, which is 3/2, and we want to know what is theta, so we do arc sine root 3/2, which is pi/3. So when x is equal to root 3/2, then theta is equal to pi/3, and when x is equal to a half, then theta is pi/6. Right, so now we substitute this, so we have pi/3 and then here pi/6. Now, so we said x is equal to sine theta, so here becomes sine squared theta, and then here is 1 minus sine squared theta, which is essentially cos squared theta. And also for dx we substitute, so where is that, cos theta d theta. Okay, so let's simplify this. So again, note that here is just cos squared theta. So when we simplify, that will, because the square root of cos squared theta is just cos theta. So we have pi/3, pi/6, sine squared theta times, so we get cos theta times another cos theta, which becomes cos squared theta d theta. Now here, we can rewrite this as sine theta times cos theta squared, and then remember that sine theta times cos theta is basically half sine 2 theta, right, from double angle formula. So this is the same as half sine 2 theta. Now when we square this, we'll get 1/4 sine squared 2 theta d theta. Right, so now we can then rewrite sine squared 2 theta as basically a half minus cos 4 theta/2, because essentially we are just using this basic relationship that sine squared theta is equal to a half minus half cos 2 theta. So in this case, because here we have sine squared 2 theta, that's why we'll have cos 4 theta. Yeah, so by doing so and then factorizing, we'll have 1/8 theta essentially. Sorry, 1/8 times 1, because that's a half, and then we'll have also cos 4 theta d theta. Okay, so now we can simply integrate this. So we can just actually take this half, this 1/8 out, and just have 1 minus cos 4 theta. So we'll have, so 1 integrates to theta, and then minus cos 4 theta integrates to 1, to minus 1 over 4 sine 4 theta. And then we have the limits. Yeah, so after calculating this, we get 2 pi plus 3 root 3 or 96.